All right, let's just jump right in. We're going to deconstruct one of the most just absolutely iconic images in modern science, right? That fiery halo of a black hole. And I promise, by the end of this, you won't just see it anymore, you're going to actually understand it.
Yeah, I'm willing to bet you've seen this picture. It's everywhere. It's kind of become our mental picture of what a black hole is. But here's the thing, it is so much more than just a pretty or, terrifying picture. Every single piece of it, that light, the darkness, that weird warped shape, it's all telling a story about the most extreme, mind bending physics in the entire universe. So let's break that story down.
Okay, first things first. Let's talk about the most obvious part, right? That incredible glowing ring. I mean, it totally looks like a ring of fire, but what's really going on is way more violent and honestly, way more interesting. So here's what's so wild. The black hole, it's completely dark. It gives off no light at all. So all of the light you're seeing here is actually coming from this thing around it, a structure that scientists call an accretion disk. It's pretty much the last brilliant scream of matter right before it gets swallowed up forever. So, what in the world is an accretion disk? Well, the best way to think about it is like water swirling down a drain. You know how it speeds up and forms that spiral? Now, just imagine that, but on a cosmic scale and, supercharged. It's all this gas and dust, maybe the leftovers of a star that got too close, all getting pulled by that insane gravity into this flat, spinning disk. And the physics going on here, it's absolutely nuts. This stuff is swirling at nearly the speed of light, and as all those particles rub against each other, the friction generates an unbelievable amount of heat. We're talking millions of degrees. It gets so hot that it glows brighter than an entire galaxy of stars. And hey, you notice how one side looks brighter than the other? That's not an accident. That's the side of the disk that's spinning towards us. The light from it gets kind of squished and amplified, making it look brighter. We're literally watching the laws of physics being pushed to the breaking point. All right, so that's the light. That makes sense. But what about the darkness? What about that perfect black circle right in the middle? Let's zoom in on that because that's the next piece of the puzzle. And this is the big question, isn't it? If this disk is one of the brightest things in the known universe, then why is there a pitch black, perfectly round hole punched right out of the center? Now, your first instinct is to say, well, duh, that's the black hole. And you're kind of right, but the actual answer is a little more subtle and honestly a lot cooler.
Okay, get this. The crucial thing to understand is that you can't actually see a black hole. The thing itself, the singularity, it's infinitely small. You can't see it. And the true point of no return, the event horizon, also invisible. So what we're looking at here isn't the black hole itself, it's its shadow. Think of it this way. This Dirk circle is the region where gravity is so powerful that any light that enters can never ever get out. It's a hole in the light. And because gravity also bends space and light around it, this shadow actually looks about 2.5 times bigger than the actual event horizon. It's basically the gravitational footprint of the black hole cast against the bright screen of the disk behind it.
All right, now for the really trippy part, the part that bends your brain a little. We've got the bright disk, we've got the dark shadow, but why does the whole thing look so warped? This, my friends, is where things get truly weird, and we get to see Einstein's craziest ideas in action. I mean, just look closely. The disk doesn't just look like a flat ring around a ball, like Saturn's rings. You can see there's a halo of light that seems to go over the top and under the bottom of that dark shadow. But how is that even possible? Shouldn't the black hole be blocking our view of the back of the disk? Logically, we should only be able to see the front half. So what's going on? Well, the answer has a fancy name: gravitational lensing. But here's what it means in plain English. The black hole's gravity is so powerful that it doesn't just pull on things, it literally bends and warps the fabric of space and time itself. So, just like a magnifying glass or a weird lens can bend light, the black hole's gravity grabs onto light rays and twists their path. This is the perfect way to visualize it. So just imagine light from the back of the disk, the part that should be hidden from us. As that light travels out, some of it gets snagged by the black hole's gravity. It gets pulled up and over the top of the shadow, and other rays get pulled down and under the bottom. And then that gravity redirects that light straight towards us here on Earth. So what we're seeing in that halo is literally the light from the back of the disk. We're seeing behind the black hole. It's folded light. Okay, so let's put it all together. We've got the light, we've got the shadow, and we've got the mind-bending warp. Let's see how they all combine to make this one single, unbelievable picture. So here we are back at the beginning.
But I bet you see it completely differently now, don't you? You don't just see a blurry donut. You see the shadow, the point of no return. You see the superheated accretion disk glowing brighter on the side that's racing towards us. And now you see that impossible halo of lens light from the back, all bent around for us to see. It's not just three different things. It's one single incredible system, all being conducted by the invisible hand of gravity.
You know, someone described it as a cosmic funhouse mirror, and I think that just nails it. That's exactly what this is. It's a distorted, warped view, but it's showing us something real. It's a true picture of what the universe looks like right at the very edge of reality, where all the rules we thought we knew just break. So I want to leave you with this one final thought. We've just seen, with our own eyes, how one invisible force, gravity, can literally bend light and reshape our view of reality. It really makes you wonder, right? What other invisible forces are out there right now, quietly shaping the universe in ways we can't even begin to imagine?